Hello everyone, welcome to today's class. This is teacher Simon taking you through probability and statistics 1. This is paper 97001/53 for May-June 2025, and this is part 2 for questions 5 to 7. Question 5 is coming from basic probability. Bag A contains 6 red marbles, 5 blue marbles, and 1 green marble. Bag B contains 5 red marbles and 3 blue marbles. A marble is chosen at random from bag A and placed in bag B. A marble is now chosen at random from the bag. Draw a tree diagram to represent this information. Okay, now let us first see what we are having here. We have bag A. Okay, bag A. It has 6 red marbles. Bag A, 6 red marbles, and then 5 blue marbles, then 1 green. Okay, then we have bag B, which has 5 red, then 3 blue marbles. That means it has 0 green marbles. Now I'm going to have bag A. Let me just shift it and put it here. And there are 3 outcomes for every pick. So I'm going to pick. When I pick, there is one there, there's another one here, and then there's another one here. And I'm putting these ones in bag B. See that? Even here in bag B. And also this one in bag B. Now, when I pick, I can get red from A, then blue from A, and then also green from A. First of all, what is the probability of picking red from A? It is going to be 6 out of 12. Because when you add everything, it is 12, right? And then this one will be 5 over 12. Then this one will be 1 over 12. Now, when I pick red from A, and then I add it here, reds are going to be 6 in now bag B. So 6 red, but then 3 blues, they remain like that, okay? Now I'll put 3 blue. I don't need to put 0 green, okay? Because I have only those 2. So that means when I'm picking from here, I only have red from B and then blue from B. The probability of picking red from here is 6, then out of the 9, and then this one is going to be 3 out of the 9, okay? Now when we pick blue from A and then we put it in B, blues are going to be 4. So we shall have 4 blues and then 5 what? Reds. Then picking from here, we shall get red from B and also blue from B. So the probability of picking red from here is going to be 5 out of 9, and then this one is 4 out of 9, okay? Then after that, we are going to also put green in here. Now, when we pick green from A and then we put in B, we shall be having 1 green here. So the reds are 5, blues are 3, okay? And then 1 green. So that means here we are having 3 outcomes when we pick. It is either red from B, blue from B, or green from B. So the probability of picking the red from here is going to be 5 over 9, not so? And then what else? This one's going to be 3 over 9 and then 1 over 9, okay? Now this is going to be our tree diagram. I can leave it there, or just consider that like that, but then I write the smaller one without these very many things. So this is what we are going to have. We have the 3 branches. So from A we have red from A, blue from A, and then green from A. Here we are seeing 1 over 12. Then here it is 5 over 12, and then this one is 6 out of 12. Then we have 2 branches here. we have 2 branches here, and then we have 3 branches here. So red from B, blue from B, we see 6/9, then 3/9. Then red from B, we see 5/9, and then 4/9, which is blue from B, then red from B, blue from B, green from B. This is 1/9, this is 3/9, and this is 5/9. So I can say this is my tree diagram. Okay, so that is that. This one was just for working out, okay, with these boxes. In the tree diagram, we don't need these boxes, okay? That's why I have taken them out, and then we are taking this one. Part B, find a probability that both marbles chosen are of the same color. So probability of same color, that means we can get only reds. So red from A, red from B, or we can get blue from A and then blue from B. Then we can also get green from A, then green from B. So what are our probabilities? Red from A, red from B, so 6/12, then times 6/9. 6/12 times 6/9. All means addition in probability. Then blue from A and then blue from B. Blue from A, blue from B, we have 5/12 and then 4/9. 5/12, then 4/9. Then green from A, green from B, 1/12 and then 1/9. 1/12 times 1/9. 6 times 6 is 36. 12 times 9 is 108. This will be 20 out of 108. And then this will be 1 out of 108. This will be 56, then 57. So we have 57 out of 108. And we can simplify this one by 3. This will be 19. And then by 3 here, we shall get 36. So it is 19 out of 36 as our final answer. Then part C, find the probability that the marble chosen from bag A is blue, given that the marble chosen from bag B is blue. That is what we call conditional probability. Bag chosen from A, the marble chosen from A is blue. So blue from A, given that the marble chosen from bag B is blue. So blue from B. That means we shall get probability of B from A intersection B from B. Then we divide by probability of blue from B. You see? Now for B from B, blue from B, this one is big, okay? It is going to have, we can have, check here. So we have it here. We have this one here, and we have this one here. You see that? So meaning we can have red from A, then blue from B. We can have blue from A, then blue from B. Then we can have green from A, and then we get blue from B. So the second one has to be what? Blue. Okay, now let us compute this. BA, blue from A, blue from B. We have even gotten it here. This is the one here. 5/12. That is 5/12 times, it is 4/9. 4/9. Then we divide by, again, I'll put it here, times 4/9. Now, red from A, blue from B. Red from A, B, then B from blue from B. That is 6 over 12, then 3 over 9. 6 over 12, then 3 over 9. And then lastly, I have GA and then BB. GA, then BB. That is 1 over 12, then 3 over 9. 1 over 12, then 3 over 9. So that is what we are having there. Now let's compute this. Of course, up here we are having 20 out of 108. Not so? Then down here we are having, this is 18 plus 20. 18 plus 20, that is 38. Then plus 3, that will be 41. Not so? So if we have 41 here out of 108, then this one will somersault, and then we get our answers 20 out of 41. Okay, you'll get 20 out of 108, then times 108 out of 41. So this one will cancel, right? And then you get your answer as 20 out of 41. Question 6 is coming from normal distribution. A company sells bags of pasta. The masses of large bags of pasta are normally distributed with a mean 2.50 kilograms and standard deviation of 0.12 kilograms. Part A. Find the probability that the mass of pasta in a randomly chosen large bag is less than 2.65. Okay, so probability of X less than 2.65. We standardize this. Where there is X, we are going to put Z, then less than, but remember Z is equal to X minus mean, then divide by the standard deviation. So we shall have our X here is 2.65 minus the mean is given as 2.50, then divide by the standard deviation, which is 0.12. So this one simplified, it is going to be Z less than 2.65 minus 2.5, then we divide by 0.12. We get 5 over 4, which is the same as 1.25. 1.25. So when I sketch the normal distribution curve, this one is a positive value, so it is on the right of the mean. And the mean of a standardized normal distribution is always what? 0. Now here, we are having all of this one here. That is the probability. That is the region. Now, when you go to our normal distribution table, and this is exactly what they give, okay, for the less than. So let's go and check it out. When you come to this normal distribution table, which they give you in the list of family, remember we are supposed to look for 1.25. So this is 1.2. Then the 5 has to be here. So you merge them. And this is the one you're supposed to get here, okay? 0.8944. I'll write 0.8944, but I can write to 3 significant figures, okay? Because even those answers from the table, they are rounded off, okay, to 4 decimal places. There's a calculator you can get on the phone, and then it gives you over 12 decimal places. You get it? So these are just rounded figures. You can also use a calculator. So you press mod, then you go to start, which is 3, then you press SC, start comes on your calculator, okay? Then you press shift, then 1, that is where there is start and distribution, you press 1, and then you go to option number 5, that where you see distribution, that is for normal distribution. P is for less than, R is for greater than, okay? And then Q, this is Q here, from 0 to a certain value. Then P is all of this region less than that given Z value. And then R is this other region here above a certain Z value, okay? So this is less than, then we shall pick P, which is option 1. You just put that 1.25 and you get the answer. But the calculator here, for it, it gives 5 decimal places, okay? 0.89435. You see that? So to 3 significant figures, do you see that we still have the same answer, 0.894? Cool. Then the next one, they are saying that a restaurant manager buys 160 of these large bags of pasta. Part B, Find the number of bags for which you would expect the mass of pasta to be more than 1.65 standard deviations above the mean. This is a part that plays students like nothing. We are having probability. They are saying you'd expect the mass of pasta to be more than 1.65 standard deviations above the mean. So this one I can write it as x greater than, this is the mean, but it is the mass here is greater than, there is 1.65 standard deviations above the mean. You get it? 1.65 standard deviation, so you multiply by the standard deviation, but it is above the mean, so we put the plus on the mean, right? Then this one is going to be probability of z. We standardize this, it is going to be greater than, so we have this one here plus the 1.65, then standard deviation. Remember, you are supposed to subtract mean, then divide by the standard deviation. So you can actually see that you are remaining with this one disappears. Then this one will also disappear with this one at the end. So you get 1.65, not so? So we shall have greater than 1.65. You see? Now, from here, I can use my calculator. Okay? If you are using a table, then you can say, you just go to this one. Let me sketch something small here. I have 1.65 here. But remember, in the normal distribution, they give you this region here for the less than. So meaning this one for the greater than, it is going to be 1 minus this other one here, right? Probability of z less than the 1.65. So you have 1 minus, let's go and look for 1.65. So when we come to our table here, 1.6, we can see it here, then 5 is here. So when we come down here, it is then going to be 0.9505. 0.9505. When we subtract, what do we get? 1 minus 0.9505. So we get 0.0495. Now here I've used a tab. Okay, so when I use a calculator, I don't even need to write all of this. You see? So for the calculator, this is what we do. Remember, my start is still on the calculator. So if it is there, then I can just proceed with shift, then start. Distribution is 5. And then we have, this is greater than. So for greater than, then I'll just put 3. That is for R. Then I put 1.65. You see what I get? 0.049472. 0.049472. This is from the calculator. Right away. You see? Now, this answer here to 3 significant figures, it is going to be 0.0495 also. You see that? Now, expectation, you get just the probability and then times the number of these bags. So expected number of bags is going to be 160, then times the probability we have gotten 0.0495. You can use this one, you can use this one, no problem, whichever you want. So what do we get here? 160 times 0.0495. We get 7.92. But this implies you can have your answer as 7 or 8. Because a bag, there's 7, we have 7 full bags, and there is no bag which is like 0.92. That means it is almost full. So if it is almost full, that means you have used the 8 bags. You get it? So you can write your answer as a 7 or 8. You can write one answer. Let me make it clear. write one answer. Your answer should either be 7 or 8, but don't go to an exam and then you write 7 or 8 like the way I've done here. You get it? Okay. The masses of small bags of pasta sold by the company are normally distributed with mean mu and standard deviation sigma. Tests show that 77% of these bags have masses greater than 1.26 and 44% of them have masses less than 1.35 kilograms. Part C, find in either order the value of mu and the value of sigma. Okay, now we have probability of x greater than 1.26, which is equal to 0.77. Okay, this is what they said here. Now we need to standardize this. We have z, then greater than, we say z minus. We are going to have x, which is this 1.26, then minus the mean, then divide by the standard deviation, this one, but we don't know the z value that gives us this. Okay, so I'll just put here z1, which is equal to the 0.177. Now here I'm going to have my z1, which has to be equal to the phi inverse, okay, of this 0.177. I'm supposed to go into the normal distribution table. In the body, I look for the 0.77. Then when I see it, then I can read off the z values, okay, which give us this. Now, from here, we can see that we have something like this. Before you get the z value, first draw these normal distribution curves to judge whether z is negative or positive, because it can be either of the two. So I can say, let's say z is here, that's z1. It can be a negative or it can be a positive. Remember, the mean is 0. So on the left, then that means the z is negative. Then on the right, it is positive. Now, based on what we are having here, we are supposed to consider the region that is greater than z1. So greater than z1, we can see this one here on the right of it, okay, or here. And by the way, this is all z1. This one is not z2. Okay. Now from here, you ask yourself, which of these two can give me the 0.77? First of all, we know that for any normal distribution table, curve, this part here is 0.5 and this one is also 0.5. That means this one is going to be less than 0.5. Not so. So since already this one is 0.5, half of it, that means there is something that we can add on here, and then the probability is going to be greater than 0.5. So implying our z value is going to be negative, not positive. You see that? So this one will be off, and then we take this. So we are having the negative z value. Do you see that? Then we need to go and find this value here. Now let's go to our table. When you come to the normal distribution table, we are supposed to look for the 0.77. But before you do that, when you are looking for the z values, always check out this small table down here. Okay? But this is for 0.75. This will be the z value. This is 0.9. Then this is the z value. But for 0.77, we can't see it there. So we go in here and then we look for it. 0.77, I think it has to be around here, because this is 7704. You see that? So I'll pick this one here, and the z value here is 0.7, then 3. But then there is something that we have to add on to get to the 0.77. So I will have 0.7700 minus, this is 0.7673. 100 minus 73, don't you get 27? We shall get 27 here. The rest will be zeros. Okay. Now we go this side and we look for 27, which is here. Do you see it? Then you pick this other value here. Okay, so now that means our z value is going to be 0.7. You see this 7, then there is a 3 here, and then there is a 9 here. 7, 3, 9. Are we there? So z1 here is going to be negative 0.739. I said we go to 0.76 and 7673. Then we subtracted it from 7700. We got a what? A 27 here. Then we went to this other side to look for it. Then we found it at, it was under, add what? 9. So that's why we have this one here. Okay, since z is equal to x minus mu over the standard deviation, then we can have negative 0.739, which is equal to our x is 1.26, then minus mean, then out of the standard deviation. If we can cross multiply, then we can have negative 0.739 times the standard deviation, then 1.26 here minus mu. I can take this one this side and then take this one here, making mu the subject. So meaning mu is going to be equal to 1.26, then plus 0.739 sigma. And this is my equation what? 1. So I'll keep this equation. Then I'll go to the next one they gave us here, which is 44% for this. So we have probability of x less than 1.35. This one will be equal to, it is 44, so 0.44. Standardizing this will be z less than, let's say z2, since I used z1 here. This one will be equal to 0.44. Even here, I will sketch these two normal distribution curves to judge whether z is positive or negative. So I can put it here. I can put it on the right here. Okay. Now, here we are supposed to look at the left of it. So left of it is here, and then left of it is here. Of course, since this is 0.5, then plus something here, this one is going to be, the whole value is going to be greater than 0.5, not so. So it cannot give us the 0.44. So this means that this one here is off, and we are having this one here. Also z2 here is a negative. So we shall put negative z2 here is going to be equal to the phi inverse of the 0.44. But since in our normal distribution table, we don't have values which are less than what? 0.5, because they give for this one, for the less than, all of them, the simplest, the smallest you are going to have is 0.5 because it is at z is equal to 0. So you have the whole of this. You get that? Now, any z value that goes beyond this 0 to the right, that you are going to be adding something onto the 0.5. So that means you're going to have something greater than what? 0.5. So since z, the z value here is just a boundary, okay, then we can use the other which we can get. So if this is the 0.44, okay, by the way, the whole of this is what? 0.77. So 1 point, I would say 1, then minus the 0.44, okay? So such that I get this one for the bigger value that I can get from the table. So negative z2 is equal to the phi inverse of, this one is going to be 0.56, yes. So let's go to the table and then we look out for this value here. We are looking for 0.56. So 0.56, I think, has to be around here, because you can see this is 5636. So that one is already bigger than 0.56. Now let's check this one here. So we are taking this smaller one here, which corresponds to 0.15, right? So we have 0.15. 0.5. Then there is something we have to add on here. That is 0.5600, then minus 0.5596. 600 minus 596, you'll get a 4. So that means the rest are going to be 0 zeros. Not so? Then when we go to this side, we are looking for a 4, which is here. Then we take a 1 here. So we shall add it here. Okay? So we went and then we added a what? A 1. Remember, we have had 0.5600 minus 0.5596. Then this one gave us a what? A 4. We went this side and then we found the 4 under add 1, right? So meaning our Z2 is going to be negative 0.151. Again, we shall have this negative 0.151, which is equal to x is 1.35 minus the mean out of the standard deviation. When we cross multiply, we shall have negative 0.151 times the standard deviation, then it's equal to 1.35 minus mu. Okay? Now, from here, I can make mu the subject, so bring it here, take this one this side, right? So we can have negative, mean is equal to 1.35, then plus 0.151, then times the standard deviation. Then this is Roman 2. Now, I'm having these two equations, so I can solve them simultaneously. Solving 1 and 2 simultaneously, I just equate them, not so? So this one here, okay, then we equate it to this one here, just like that, and then we collect like terms together, so 0.739, then minus 0.151 of the standard deviation. So I brought this one here, then take this one this side, okay? All right, so this one is going to be equal to 1.35 minus 1.26. So meaning standard deviation is going to be 1.35 minus 1.26, then out of 0.37, no, pardon me, here it is 0.739 minus 0.151. Okay, as a fraction, what is it simplified? 1.35 minus 1.26, and then down here we have 0.739 minus 0.151. We get 15 out of 98. 15 out of 98. But to three significant figures, this one is going to be, it is recurring from the 5. So it is going to be 0.153. 0.153. Three significant what? Figures. Then we can now substitute for mu in any of the equations. So I can say mean is going to be, I can substitute here 1.26, then plus 0.739 times the standard deviation. I don't need to substitute using this one that is rounded off. You can substitute using this. That's why I've gotten the fraction here, okay? 15 out of 98. And then what shall we get to three significant figures as our value of mean? 1.26, then plus 0.739 times 15 out of 98. We get our answer as 1.37. 1.37. Three significant figures. So that is that. Question 7 is coming from Permutations and Combinations. They are saying a set of friends consists of 7 men and 4 women. 3 of the men are brothers, Ali, Ben, and Charlie. Part A, find the number of different arrangements of the 7 men in a line in which Ali and Ben do not stand next to each other. Okay, now when we are arranging these people, we can see that there are two possibilities: Ali and Ben standing next to each other, and also when they are not standing next to each other. But if I consider without any restriction, so in that no restriction, I can have Ben and Ali standing next to each other, also plus when they are not standing next to each other. You get it? So that means I can consider first no restriction. Okay, no restriction. So for no restriction, how many men are there? There are 7. So we shall have 7 factorial. And then I can consider Ali and Ben together. Okay, they are standing next to each other. I'm going to have 1, 2, 3, 4, 5, 6, 7. Maybe Ali and Ben are here. Now this one becomes one group. Okay, so this will be 1, then 2, 3, 4, 5, 6. So to arrange those ones in a line, it is going to be 6 factorial. But again, when these ones are seated, when they are standing together, they can stand in 2 factorial ways, because you can have Ali here, then Ben here, then you can also have Ben here, and then Ali here. You get it? So that is that there. That means when we are looking for Ali and Ben not together, then this one is going to be this total with no restriction, then minus when they are standing next to each other. So what does this one give us? 7 factorial minus 6 factorial times 2 factorial is 2. So what do we get here? 3,600. As simple as that. Alternatively, these are 7 men. Okay, so if there are 7 men, that means I'm going to consider 5. So first take off these 2, then we remain with 5, right? So there is maybe man 1, man 2, man 3, man 4, man 5. You see? Then from here, these are the spaces where I can place these 2. There is a space here, there is a space here, there is 1 here, 1 here, 1 here, and 1 here. That means in here, I can put Ali or Ben, wherever. You see that? So that is where we are putting Ali or Ben. Now, that means, first of all, these are 5 men. We can arrange them in 5 factorial ways. Are we there? Then, Ali and Ben, how many spaces do we see? 1, 2, 3, 4, 5, 6. Out of the 6 spaces, I'm only going to use 2. So I'll say out of the 6, permute these 2 for Ali and Ben. So what do we get here? 5 factorial times 6 permutation 2. You get 3,600. So either way, you get it. Then part B, find the number of different arrangements of the 7 men and 4 women in a line in which all men stand together and all women stand together. That means here I'm going to have 2 groups. Not so. I have a group of men. How many are they? They are 7. 1, 2, 3, 4, 5, 6, 7. Then women, 1, 2, 3, 4. So I have this group of women, and then I have a group of men. So maybe this is man 1, man 2, man 3, man 4, man 5, man 6, man 7. Remember, these ones can be anywhere. It doesn't mean that I'm putting man 1 has to be standing here. That's why we say this is 7 factorial. Anyone can go wherever. Then for the group of women, I can have woman 1, woman 2, woman 3, woman 4. Okay, so I have here 4 factorial. Then here I have 7 1 factorial. So the number of different arrangements, Now this one is going to be 7 factorial, then times 4 factorial, but we have two groups. So this group can be here, and then this one can be there. You get it? So times 2 what? Factorial. So what do we get all together? 7 factorial times 4 factorial, then times 2 factorial. We get 241,920. 241,920. As simple as that. Then part C, in how many ways can the 7 men and 4 women be divided into a group of 6 and a group of 3 and a group of 2 if there are no restriction? Okay, so we have 1, 2, 3, 4, 5, 6, then 1, 2, 3, and then we have 1, 2. So if we are having, first of all, the total here is what? 11. So that means here we shall have 11, then combination what? 6. You are choosing, you don't have any restriction. Now 11 minus 6, what do you get? 5. Not so? Then out of the 5, choose 3 and you put them in this group. Are we there? Then after taking off the 3 from the 5, you remain with what? 2. That means you have 2 here, then combination what? 2. So meaning we shall have 11 combination 6 times 5 combination 3 times 2 combination what? 2. What do we get? 11 combination 6, that is 462. Then times, we have 5 combination 3. And from there, we have 2 combination 2 is a 1. That is 4620. 4620. As simple as that. By the way, it doesn't matter where you are starting from. I can begin from here. And then I say 11 combination 2. Then after that, after subtracting 2, I'm going to have what? 7 are remaining. Then you have, you have 9. So 9, then combination what? You put the 3 people here. Then from there, 9 minus 3, you remain with the 6. Now those 6, then you put them in here. You see that? You still get the same answer. And very many, you can begin from here. You say 11 combination 3, then times, this will be 8. Then maybe you say combination 6. Then you are remaining with 2. Then 2 combination 2, whichever you want. Okay? So just because I started with a group of 11, with a group of 6, it doesn't mean that that has to be the only option we have. Then part D, they are saying that the 7 men and 4 women are divided at random into a group of 6, a group of 3, and a group of 2. And then find the probability that Ali, Ben, and Charlie are all in the same group. Now, we are going to have Ali, Ben, and Charlie in a group of 6. Are we there? In a group of 6. So we can have 1, 2, 3, 4, 5, 6. Ali, Ben, and Charlie are already there. Okay? That means we shall get the 11 minus these 3. What are you having? 8. Are we there? So out of the 8, you only need how many people? 3. Do you see that? Out of the 8, you only need 3. So out of the 8, we need 3. Then there is a group of 3. 1, 2, 3. And there is a group of what? 2. So from here, now you have 5. Not so? So from the 5, you choose 3. Are we there? And then the 2 that are remaining, then you will put them where? Here. Is that okay? Then let us also consider Ali, Ben, and Charlie in a group of how many? In a group of 3. So in a group of 3, then we can have 1, 2, 3. Then there is also 1, 2, 3, 4, 5, 6. And there is also what? 1, 2. Ali, Ben, and Charlie are in a group of 3. That means out of the 8 that are remaining, you don't need any in this group. Now, out of the 8, you take away 2, you put them in here. And then the 6 that are remaining from here, you put them in this group here. Are we there? It doesn't matter whether you begin with this one and then you say 8 combination 6, and then here you will have 2 combination 2. Okay, 8 combination 6 is the same as 8 combination 2, so long as these numbers can add to give you this number, the n. Okay, then what else do we have? Ali, Ben, and Charlie, if they are all in the same group, then they cannot be in a group of 2 people. You see that? So those are the only options we have. So we shall have 8 combination 3 times 5 combination 3, then times 2 combination 2. Then we shall add 8 combination 0 times 8 combination 2, then times 6 combination 6. Okay, so what do we get here? 8 combination 3, we get 56, then times 5 combination 3, that is 560. Actually, 5 combination 3 is a 10, 2 combination 2 is a 1, so that is 560. Then plus, what is here? 8 combination 2, that is the only I think computation we have here, because this one is a 1 and this one is a 1. So 8 combination 2 is the same as 8 times 7, that is 56, not so? Then divide by 2, that will be 28. Now when we add here, this one is going to be 588. You see that? Then probability here, probability is going to be this number we have gotten here. Then we divide by choosing these people. We are choosing these people and we are putting them in these groups, okay, without any restriction. And that is what we were given up here. You get it? In these groups with if there are no restrictions. So I will just divide by 4620. 4620. Maybe I can write it simplified. What would be then the answer? But even if you leave it as 588 over 4620, they can still give you your answer. So 588, then out of 4620, we get 7 out of 55. 7 out of 55. Or you can write it to 3 significant figures. So that is that. This has been it for the second part of the paper. Thank you so much for watching. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.